Final example, we've got a tank for holding water. Well, first step we need to do, we need to understand what's going on. Tank for holding water is shaped like a circular cone with its point towards the ground. What does that look like? Oh, yeah, I've got okay, yeah. So you draw something circular and then it comes to a point like a cone. Cool, makes sense. The tank is 10 feet tall and has a diameter of 6 feet at its top. So let's put that into this. So it's 10 feet tall and has a diameter that is 6 feet across. So 6 feet across. What is the volume when the tank is full? And then we've got a second part, what is the volume when the water is only 5 feet deep? So let's just start off by breaking it here and we'll answer what is the volume in the tank when it is full. So our first thing makes sense. We've got this cone full of water. We fill it up to the top. How much water is going to be in it? So second part, second idea, we want to get what we need to know here. So it seems like it'd be useful to talk about the height, right? Well, we actually know what the height is. So height, h will equal the height of the cone. And let's say d equals, we were told the diameter, so let's say the diameter. Even though these are really just going to be values, we can talk about them as if they're like that. And that seems like everything we need to know right now. So let's go and let's see, do we have a good way to relate these two things together? How can we relate the height and diameter of a cone to its volume? So we might go, well, how do I get volume of a cone? I've learned this before. They told me in geometry. Right, it's this. We remember the formula. Or maybe we don't remember the formula. Like, well, I know I've been told it. So if you've been told it, it's out there on the internet, right? Or it's in a math book. Just either crack open a math book or do a quick web search and you'll be able to find it really quickly. And you find out that the volume of a cone is equal to 1/3 times what the volume of its cylinder would have been. The volume of its cylinder would have been the area of the top, pi r squared, the circle, times the height of the cylinder. Okay, now at this point we go, wait a second, we are talking about volume. We want to know what volume is, right? So volume equals question mark. That's what we're really searching for. But did we have r show up before? No, we didn't have r show up before. So let's make a new one. R equals radius, right? So we were told some stuff here. We were told the diameter is 6 feet. So how does a radius connect to that? Well, we go, oh, right, diameter is just double the radius. Radius is half the diameter. So r equals 3, right? Halfway would just be, if the whole thing is 6, then halfway is going to be 3. So r equals 3. Our h equals, our height was 10 feet tall. So h equals 10. Now we've got only one unknown left in this equation here. V equals 1/3 times pi r squared times height. We know what the radius is. We know what the height is. Pi is just some number. 1/3 is just some number. So the only thing we're looking for is volume. Real easy. We just plug our numbers in at this point. So fourth step, just solving it. Our volume is equal to plugging in the values. 1/3 times pi times 3 squared times 10. So that's going to wind up being the 9. The third here will cancel the squaring that we've got here. So we've got pi times 3 times 10, or 30 pi. And we have to talk about it in terms of units. So if it's volume, and we've been doing feet before, it must be cubic feet. And there's our answer. All right. Now, what if we wanted to do this other portion of it, right? So we'll change over to a new version. Now it's nice because it's going to follow a lot of parallel ideas, so we can just use what we've already figured out. So instead of being 10 feet tall, it's only 5 feet tall, right? So the water really only comes up to here. Now if that's the case, if the diameter is 6 up here, is the diameter going to be the same down here? No, that makes no sense, right? The diameter can't be the same because it's a cone. It shrinks down the farther down we get. So if we were all the way at the bottom, the diameter would be 0. If we go all the way up to the top, it'd be 6. It makes sense that the diameter is going to be half of what it would have been before because we are now at half the height. So the diameter in the middle is 3. So that means our radius is equal to 1.5. Our height is 5. And that same formula from before, our volume formula for a cylindrical cone, still works. So volume equals 1/3 times pi r squared times height. We plug in 1/3 times pi times 1.5 squared times 5. We work that out. 1/3 times pi times 11.25 simplifies to 3.75 pi, and it's in cubic feet. And there is our answer. We're basically following the same outline we did before, so we don't have to worry about doing it step by step, because we can just work from our previous idea. We figured out how it was done in the complex way. Now it's just a matter of using new values and making sure that the values we're using are right? R changes because we're at a different place. Height changes because we're at a different place. But all the relationships, they're still the same, which makes sense. We want to be thinking about it, but it makes sense that all the relationships are the same because we're still just looking to figure out what is the volume inside of this cone. It's just now a cone inside of a cone, right? Cool. All right. Hope that made sense. Hope that gives you a slightly better understanding of how to approach word problems. Don't be that freaked out by them. It's just a matter of breaking it down and understanding what's going on, setting up what you're looking for, figuring out the relationships that connect what you're looking for to what you know, and then finally just solving it like a normal math problem. All right. We'll see you at Educator.com later. Bye.